For today's lesson, you'll need your Unit 3B Day 4 notes, a pencil, and a ruler or straight edge. In previous units, we've talked about how we can determine if a function is even, odd, or neither based on a graph and a table. So let's try to recall that knowledge graphically. I have 7, I believe, graphs here for you, and I'd like you to tell me, 1, what kind of function type it represents, and 2, if it's even, odd, or neither. Pause the video, and then we're going to check your responses. Our first graph represents our square root function. Again, when we're trying to graphically determine if something's even, we want to see if it's symmetric to the y-axis. So we could draw our line of symmetry and see that if one side, what's happening on the graph of the y-axis is also happening on the other side. This is not happening here. We also can see if it's symmetric through the origin. That means I could take any point on my function and draw a line through the origin, and there should be a point on the other side that matches. Again, this is not happening in this case. So since we don't have either symmetry with the y-axis or the origin, this would be a neither function. Our second graph represents our absolute value function. When working with our absolute value function, again, we want to look at the lines of symmetries. If I draw my line of symmetry through the y-axis, I can see that I have a mirror image of each other. This would mean that I have an even function. Our third graph represents an exponential function. In particular, this exponential function is represented by the equation f of x is equal to 2 to the x power. Again, we want to look for our lines of symmetry. So if I draw my line of symmetry along our y-axis, I'm looking for mirror images on each side, and it doesn't appear that I have it. Again, for odd functions, we want to look at having some symmetry through the origin. So what happens on one side of my function would be symmetric to the other side. So if I look at those two symmetry tests, I can see that neither one works for this function. So it would be a neither. Our fourth one is our cubic function. And so we know it's x to the third power. Again, we want to look at our symmetries. If I draw my vertical line here along our y-axis, I'm looking to see that we have mirror images on each side, and that's not happening. So what I want to do is pick a point on my function and see if it's symmetric through the origin. So I want to draw a line through the origin and see if it has a match on the other side. And I can see for these, I do have symmetry around the origin where I have those points being repeated. So this would be our odd function. Our next graph is one of a linear function. And again, we want to look for symmetries, whether we've got some along the y-axis or through our origin. So I'm going to see which of those tests I can utilize, and I have some symmetry through the origin, making this an odd function. Here we have our quadratic function. And again, we want to see if it's symmetric about the y-axis or through our origin. And so if I look at my y-axis, I can see that I do have mirror images on each side. Therefore, it would have to be an even function. Here we have our next graph, and this is representing our rational function, and here's our equation, f of x equals 1 divided by x. Now to try my two symmetry test, I would draw my line for my y-axis and see if I have mirror images over each other, and I don't. So then I want to see if I pick a point on one part of my function and I draw it through the origin, does it have a match on the other side? And here I can see with those test points they do have some symmetry through the origin, therefore this would be an odd function. Our last graph is a periodic function, and this is our sine function. Again, we have repeated values. Notice how our range is restricted between -1 and 1, and it cycles through our data. If I drew my vertical line along my y-axis to look for symmetry, I can see what happens on one side is not happening on the other. So it can't be even. So I want to pick a point on my function and see if I draw a line through the origin, does it have a match on the other side? And here I can see that I do have symmetry through the origin. So this would be an odd function. Now with our sine function and some other periodic functions, we have to remember because there's repeated values that will come up again and again as we cycle through the data. So here, if I look at the sine of 90, my output is 1. And so if I go through my data, I can go back and see that I would have an output of 1 again here at -270 degrees. I would then have another 1 for my output if I went to another 90 degrees past our 360. So again, by cycling through these data values, we have to remember that they'll keep reappearing and how these outputs will generate over and over again. With periodic functions in terms of transformations like we were talking about yesterday, we have to think about what transformations would give us the same output values for our functions. So in this case, if I ask for the sine of 90 degrees and it has an output of 1, we have to think about, well, what other transformation would also give us an output of 1? Well, if I went 90 degrees the other way, here I have an output of -1. If I took this function and took the outputs and multiplied it by -1s, if I reflected it over the x-axis, that would be the same output as my original. So the opposite of sine of 90, the opposite of negative sine of 90 would give us a value of 1. Just like the sine of 90 gives us a value of 1. This is something to keep in mind as we're doing our transformations and thinking about how we can algebraically prove whether or not a function is even, odd, and neither, trying to tie it back to those connections that we did graphically. If you turn your page, we're going to practice again using our definition of what makes a function even and odd, proving how we can take an equation in standard form and determine whether or not the functions are even, odd, or neither. And so we're going to do some practice with these first 4 together, and then you're going to do some individual practice on your own for the rest of the problems. So let's take a look at our first function in number 1. Here we have a quadratic function, f of x equals 3x squared plus 4. What we're going to do is we're going to compare our original function to 2 transformations. One where we're reflecting it over the y-axis, and the other when we're reflecting it over the x-axis. So we're going to set up our 2 rules. Using what we learned about compositions and our transformations, we're going to see the impact that it has on the original function. So again, if I do f of the opposite of x, affecting our inputs, taking those opposites, we want to see how that's going to impact that original function. Well, negative x times negative x would be a positive x squared, so we would have 3x squared plus 4. Here, if I took all the outputs and reflected those, taking the opposite, we'd have a negative 3x squared minus 4. So we want to see, do any of these transformations match our original function? And here we can say when we take the opposite of our input, it matches the original. Well, when that happens, we know we have an even function. So our function f of x equals 3x squared plus 4 is even. Our next function, j of x equals x to the third plus 7. Again, we're going to look at those two transformations and see if that determines an even, odd, or neither function. So we're going to take the opposite of our inputs and the opposite of our outputs and see what happens. So here, negative x times negative x is x squared, times a negative x again would be a negative x to the third plus 7. If I take the opposite of my outputs, I'm going to have a negative x to the third minus 7. So again, we're looking to see if either of these match our original function, and they do not. We're also going to look to see if either of these are matches. They are not. Because they do not follow either rule, we would say this is a neither function. Our third function, k of x, equals the opposite of the absolute value, x plus 2. Again, we're going to compare our original function to our two transformations when we take the opposite of our inputs and the opposite of our outputs and see what results. So we're taking the opposite of our inputs. We've got the absolute value of negative x, which is measuring the distance of x. And here we're taking the opposite of our outputs. And so if we look at the results, again, we want to see if any match the original or if the two transformations match each other. Here we can see that when we take the opposite of our inputs, it's the same as our original. Therefore, it would be an even function. Our fourth function, g of x, equals 2x to the third minus 4x. Again, we're going to look at the two transformations and see whether or not they match the original or each other to determine whether or not it's even or odd. So we're going to take the opposite of our inputs and see what results, and take the opposite of our outputs and see what results. So if we do this, a negative times a negative is a positive, times a negative would be a negative. A negative times a negative is a positive, so we would have a negative 2x to the third plus 4x. By taking the opposites here, we would have a negative 2x to the third plus 4x. Neither of these match the original. However, they match each other. Since they match each other, that's following our rule, determining it's an odd function. Now it's your turn to practice algebraically determining whether or not our functions are even, odd, or neither by using your two rules, looking at what happens when you take the opposites of your inputs versus the opposite of your outputs. At this point, what you're going to do is stop the video, work on your problems for your day 4 notes, so working on number 5 through 22 in your note packet. You're then going to enter your results into Socrative. So remember to go to Socrative. It's www.socrative.com. You have to enter your classroom code, We Go Miss S. You're going to enter your results into Socrative. It will be open until 10 o'clock tonight. So make sure that you don't close your tab before you have fully answered all of your results. I will take a look at those results tonight, and we'll look at them together tomorrow to see if there's any questions that we may have or any areas that we need to clarify and move forward. So again, Socrative will be open till 10 o'clock tonight. Make sure you enter in all your final results, and we'll see you tomorrow.